Hey YouTube, what's going on? Yes, I'm back again with another video tutorial or challenge of the tutorial in which I'm going to be continuing from the previous challenge of object-oriented programming. So, without further ado, let's get started with the exciting part. Right, so this one says that add methods after inheritance. A constructor function that inherits its prototype objects from a supertype constructor function can still have its own methods in addition to the inherited methods. So basically what it's trying to say is that if the if there are two classes, child and parents, the child already inherits all the properties and the methods of its parent class. However, if the child wants to introduce its own method as well and utilize that, it can do so too. Alright, so for example, the bird is a constructor that inherits its prototype from animal. So that's the bird is a constructor and is inheriting the prototype from the animal class. So bird is a child of animal in simple English. Alright. So and it's also assigning the bird's constructor to its own constructor, which is a bird of this one. Alright. So in addition to what is inherited from animal, you want to add behavior that's unique to bird objects. Here bird will get a fly function. Functions are added to bird's prototype, the same way as any constructor functions. Alright, so this is how the functions are added to the prototype of the bird. Alright, so that would be the name of the function. So this one will be the name or of the function where you want to call it. You can call this, I don't know, eat, sleep, fly, bark, run, whatever. Alright, cool. So now instances of bird will have both eat and fly methods. So in this way, the bird, so duck is an instance of a bird and it can access both eat and fly method. Alright, add all necessary code. So the dog object, which is this one here, inherits from animal. Alright, so first of all, we need to make the parent class of the dog as animal, and the dog's prototype constructor is set to dog. Alright, and then add a bark method to the dog object so that the beagle can both eat and bark. The bark method should print woof to the console. Right, so let's approach this problem with dynamic programming. You must be wondering what dynamic programming is. So I'll, I'll just clear an extremely basic concept that dynamic programming is an act of um, splitting one big problems into one or more small into two or more sub problems. All right, so in this one, our entire problem is to add methods of the inheritance. So we need to add a bug method to the dog object. Okay, that's our entire goal. How are how are we gonna split that into sub problems? So first of all, we need to um, make dog objects, make dogs so it inherits from animals. All right. So we're gonna do the child class, the child object prototype, and then this will equal to object the animals prototype, which is this. All right. So how we gonna do that? By object. Oops, I forgot to add the doors. Create, and then the parent class, I mean the parent object, which is animal and its prototype. Prototype. Perfect. Alright, now that's out of the way. Now we need to set the dog's prototype constructor to dog. Alright, so same thing again, the dog prototype, and there's a property in the prototype called constructor, so we're gonna use that and set that to, what does it say, dogs constructor is set to dog, so dog, here we go, perfect. And now uh, we need to add a method bark. How do we add a method bark? Same as how we add the constructor. So prototype, and then the name of the method, which is bark. Perfect. Okay, and this will have the bark function, which we want to call it as we want to print wolf to the console. So console.log, and then wolf. Alright, there we go. And we should be passing all the tests. Before I test the code, I just want to repeat all the steps that I did here. So first of all, I have made the dog prototype inherit from the animal prototype. So whatever the function is, whichever functions are in animal prototype, they're gonna be accessible to the dog prototype as well. And then what I've done is that set the constructor property of the dog to its own constructor, which is the dog. Alright, and then I've created a function called bark. Okay, and I mean a function called bark in the I'm sorry, I think I'm confusing myself here. I've created the dog's object's own function, which is just relevant to the dogs. So in this case, animal cannot access bark, but the dog can access bark. Okay, like dog can access eat and bark as well. All right, because dog has been in, I mean animal has been inherited by the dog. Alright, let's check if it runs properly. Have I done a mistake? Hopefully not. Yes, I have done a mistake. So where's my mistake? I've got the dog prototype. Yup, that is fine. Object. Do I have to do the object in capital? Yep, that's fine. Don't an animal prototype. My bad. There was a typo there. Do apologize for that, guys. I often do these kind of mistakes, but yeah, I need to improve. Right. Alright, now hopefully all the tests pass. Yay! Cool Aid Man says, oh yeah. See, he's excited as well. Right, go to the next challenge, which is about override inherited methods. In previous in previous lessons, that you learned that an object can inherit its behavior from another object by cloning its prototype object. Yep. So child object dot prototype is equal to object dot create parents object dot prototype. Then the child object received its own methods by chaining them onto its prototype. Yep, that makes sense. Which is child object dot prototype dot method name and then a function of its own. It's possible to override an inherited method is done the same way by adding a, a method to child prototype using the same method name as the one to override. Here's an example of bird overriding the eat method inherited from the animal. Right, so that's the animal prototype object, and it's called this eat method, and we're gonna override this eat method in the child object. So it's overriding it inherits all method from animal. Yep, and then it's inheriting the bird. It's inheriting the bird object is inheriting from the animal, and then the bird dot eat overrides animal eat and bird eat. Alright, so what he means to say is that if we want to override a parent class method, which is eat, a parent class method, sorry, a parent class object method from the child class object, then we can do that in the same way that we define the method. So each, but the key to know here is that method name that's been uh, that's being overridden has to be the same as the method name in the parent object. So eat and eat. Alright, and then you call you write your own method, whatever it does. Alright, so now it says if you have an instance, let doc is equal to new bird, which means that doc is an instance of the bird, and you call doc.e. This is how JavaScript looks for the method docs prototype chain. Alright, so if you want to call this method instead of this method, then you need to use the instance name, which is the doc, and call that method. Alright, so doc, the instance of a bird, and then the method, so followed by a dot notation. Cool. So doc goes to is method defined it? No. Bird is E method defined it? Yes. Yes. Execute it and stop searching. The this is okay. So this is how JavaScript looks for method on duck's prototype chain. Duck eats. Duck goes to E is eat defined it? No. Bird is it defined it? Yes. Execute it and stop searching. Animal.a is also defined, but JavaScript stopped searching before reaching this level. Object JavaScript stop searching before reaching this level. Right, cool. So I think what it's trying to say, according to my understanding, because all this concept in terms of JavaScript object-oriented programming is a bit new to me as well. I'm normally a .NET developer, but according to what I've understood, that uh, how JavaScript will look for this method. So it will come here, bird, okay, and then it will create a bird's prototype and inherit that from the animal's prototype, and then it won't go to animal yet, but it will continue to the bird's prototype. So it will find the function eat and then execute this function. So here, I mean, and then it executes it and stops searching. So as soon as it executes the method eat, it will stop searching. All right, and then for the animal, stop searching before reaching this. Okay, so because it stops searching and this method won't get executed because it's already executed this method, and it will stop the search, hence it won't come onto animal prototype. Alright, which means that each or for the animal prototype won't get executed. Whereas same for the object, that it stops searching, so it stops searching the animal, it stops searching for that method, so it won't even come to object because the chain is animal, object, animal, and then bird. Alright, so animal is inherited by bird, and then object is animal, no, bird is, no, but yeah, and I got, I'm being confused again. Animal is inherited by bird, and then object is inherited by animal. So 1, 2, 3, and the cycle starts again. 1, 2, 3, and loops over and over again. All right. So now it says that override fly method for penguins. So it returns alas, this is a flightless bird. Right. So override fly method, which is this one for penguin. So we would do um, penguin. So penguin dot prototype dot what was the method name? Fly. So fly and execute this function, which is called return return oops, no opening, no brackets there. So return alas this is a flyless bird. Perfect. So I think this should be fine now. Yeah. Okay. So here what I've done is that this was the parent class for penguin. So I mean bird was a parent object of penguin because it's inheriting bird prototype here. And in this case, if we don't have the fly method for penguin by itself in this block, okay, which is here, then it will execute the fly method of the bird, but we don't want that because penguins can't fly, obviously. Alright, so we have we have created a same method name for the child class, which is um, uh, object name and then prototype and then the method name. See these the method name of the parent class has to be exactly the same as the method name of the child class, and then we are just uh, um, uh, we're just creating a function. Alright, so hopefully that works. Let's see if it does. Yay, down the rabbit hole. Oh, we go. Hooray! Let's start off with the next challenge. Alright guys, I really hope you understand the concept of inheritance and how does it work with prototype and methods as well. If you don't understand it, please leave a comment below and I will be explaining in a separate video the entire concept of inheritance. Alright, so that being said, let's move on to the next challenge. Use a mixing use a mixin to add common behavior between unrelated objects. Okay, so mixin. What's a mixin now? Let's find out. As you have seen, behavior is shared through inheritance. However, there are cases when inheritance is not the best solution. Okay, inheritance does not work well for unrelated objects like bird and airplane. Uh, They both can fly, but bird is not a type of a plane, and vice versa. For unrelated objects, it's better to use mixins. Now here we go. It tells us the definition of mixin. A mixin allows other objects to use a collection of functions. Okay, so a mixin allows other objects to use a collection of functions. So here it defines a mixin called fly mixin and gives the function name. I mean, it makes it a function. So it makes fly mixin a function and it passes the object into it, and then object dot fly is equal to function parentheses. The fly the fly mixin takes any object and gives it the fly method. So that bird it's got two properties, name and legs, and then plane is got two properties, model and number of passengers. Fly, fly mixing, bird. All right, here, here the here bird and plane are passed into fly mix, which then assigns the fly function to each object. Now bird and plane can both fly. Note how the mixing allows for the same fly method to be reused by unrelated objects, bird and plane. Alright, so basically what it means is bird and airplane are not the same type of objects, so they can both fly, alright, but they are not. Bird can't be a plane and airplane can't be a bird. So because we need to reuse the code, and it's a good programming concept that reuse code multiple times or create generic functions. So that's where fly mixing comes into play. That it can be applied to any objects and gives it the fly fly method. So here airplane can fly and the bird can fly as well, but they are not the same type. That's where fly mixing comes in. So we create this method once, but we can reuse it in unrelated objects, in this case bird and plane. Alright, so now it says that yep, so it asks us to create a mixin named glide mixin that defines a method named glide, that then use the glide mixin to give both bird and boat the ability to glide. Cool. So we need to create glide mixin function. So I'm defining let because I don't want the value or the purpose of this method to change anywhere in my code base. Alright, so glide mixin and then function, and then I'm gonna pass it the object, yep, and then I'm gonna do what I want to do with the object, as in object, which is here. So call, I mean objects. So here I've just given the method name called glide mixin, and now I'm gonna do object dot glide is equal to function, and this is the actual method name. This one which is being called on this object which has been passed in function, and then I would console out console.log. What do I need to print out? That then you glide mixin to give both. Oh no. Defines a method named glide. Hang on. I'm I'm getting confused again now. Mm, Create a mixin, yep, named glide mixin, yep, there we go, perfect. That defines a method named glide, which is here, cool. Then use the glide mixin to give both bird and boat the ability to glide. So how do we do that? Glide. Is this how I'm doing this for the first time as well? So I'm not really sure if I'm doing the right thing, but let's see if I am. Alright, I think that's how it should be. And now what I need to do is I need to apply this glide mixing to boat and bird. Boat, I mean bird, and I'll just copy and paste this to boat. Alright. Hopefully this was the purpose of this task. I don't know if I've done this correctly, but let's see if I have. Alright. Yes, I did. So apparently I understand the concept. Good for me and you guys, because I hope you've understood the new concept of mixing from my explanation. Alright, let's move on to the next challenge. Alright, this one is choose closure to protect property within an object from being modified externally. So in the previous challenge, Bird had a public property name. It's considered public because it can be accessed and changed outside of Bird's definition. Cool. Therefore, any part of your code can easily change the name of Bird to any value. Think about things like passwords and bank accounts being easily changeable by any part of your code. That could cause a lot of issues. The simplest way to make properties private is by creating a variable within the constructor function. This changes the scope of the value, the scope of the variable to be within the constructor function versus available globally. This way the property can only be accessed and changed by methods also within the constructor function. So it's got the bird constructor function here, and it's got variable hashed egg, and it's assigned the value 10. Right, cool. So this dog get hash, that's a function. Get hash count is equal to function publicly available method that a bird object can use. Returned hashtags. Let doc, let ducky, the instance of new bird. The instance of a bird. Ducky dog get hash counts returns 10. Right. Here, get hashed account is a privileged method because it has access to the private variable hashed egg. This is because this is possibly because hashtag is declared in the same context as getHashedCount. In JavaScript, a function always has access to the context in which it was created. This is called a closure. Alright, so basically what it's trying to say there is whatever variable you create in the constructor function, it will be a private property. Okay, and the reason why getHashedEgg has the access to the hashtag property is because uh, they both are declared in the same block. Okay, so if uh, getHashedCount was declared outside of the bird constructor, then it won't have the access to hashed egg. I really hope this makes sense, guys. Yeah, I know that they are new concept, but hopefully my explanation is well clear. And if it's not, please feel free to ask me questions in the comments. I'll be more than happy to help you guys. All right. This is called a closure. Change how way is declared in the bird function. So we need to change this one. How do we do that? By alright, let me just read the task first. Change how way is declared in the bird function. So it's a private variable. How do we make it private? It's already in the constructor functions. So just add the word let to make it a private property. Then create a method getWay that returns the value. So create the method in there. This would be this or get weight and function and then it should return the weight, which is this one. It should be fine, hopefully, if I've understood it properly. Oops. Alright, here we go, and this should work. Let's see if it does. Heart's beating. Yay! Seems like I've understood this concept as well, but just to experiment a bit, if I put this function outside of the constructor function, it won't work. Yes, because in order for it to return the weight, it should be in the constructor function. Alright, so I'll just move it back in the constructor function and then we are good to go. Perfect. Alright, I really hope you understand all my explanation, and if you don't, then please leave me a comment below. I promise that I'll get back to you every single comments. Alright, until then, have fun coding, guys, and don't forget, practice makes perfect. So go and write some code.